so let's take a look at this problem here. On average, a Newfoundland dog weighs about 1.25 pounds at birth. Assume that at a year old the dog weighs 120 pounds. Based on these two data points, find a linear function that describes how weight varies with age. Use this function to predict the dog's weight at age 2 and at age 7, and then we'll comment on the validity model. So what I'm going to do is open up the notes for Chapter 9 for quantitative reasoning. You can find those on the SSC's website, and the Chapters 8, 9, and 10 notes and examples. And Chapter 9 starts talking about linear functions, which is what we're asked to find here. So let's go find that in the notes. Here it is. So 9A and 9B. This is going to be really helpful, these notes here. They explain what a linear function is and also what we need to do. We need to find the slope, and right down here we need to find this form, y equals mx plus b. That's what we're being asked to find. So let's write out what data we have. It says we have 2 data points, so let's write those out. We have the age of the dog in years. We have 2 of those. And we also have the weight of the dog in pounds. Now if you read the notes, you have to make sure you know which one is the independent, which one is the dependent variable. The dog's weight will depend on its age. The age won't depend on its weight, so that's why I put age in the left column. And the 2 ages are 0 years and 1 year. And then we have the 2 different weights that match up with each of those, the 1.25 and then the 120. So I'm going to use the slope formula that's on the note sheet. I'm writing it right here, y2 minus y1 divided by x2 minus x1. I'm going to use this to find the slope. Let's color code. So y2, that's the second y value, or the second dependent variable, which in our case is 120. And then y1 would be the first dependent, which would be 1.25. Now x2 would be the second x variable. Actually, let me make that match so they're both orange, because it does matter the order in which you add and subtract things. Actually, we're not adding, we're just subtracting. You just have to make sure that the y2, x2 are stacked on top of each other, and the y1, x1 are stacked on top of each other. So, having identified which one's which, let me make that line better. We have to do subtraction. Let's plug those in. So the second y value is 120, and the second x value is 1, and the first y value, 1.25, and the first x value is 0. So let's go ahead and calculate this to find the slope. Okay, so I've got my fraction, y2 minus y1, and then the x2, it's actually called x sub 2 or x sub 1 or whatever, but anyways, here's our slope, 118.75. Let me write that down. 118.75. Now what this means in words, because we took the weight, the difference in the weight, and divided by the difference in the years, this means that the dog is, we have a positive number here, so the dog is gaining 118.75 pounds every year. Alright, so that's what our slope is. So with this information, we can go ahead and create the function, the y equals mx plus b. Now in words, it's the rate of change times the independent variable plus the initial value. We have been given an initial value. Remember, the dog's initial weight when it was born was 1.25 pounds. Let's put this all together. So y equals mx plus b, that's the form we're going to follow. Y is always y, x is always x, it's the m and the b that you replace. The m is our slope at 118.75, and b is the starting point, the starting y value, I should say, which for this little pup here was 1.25 pounds. So this is our function. When they ask us for a linear function, there it is. Based on the 2 data points we were given, that would be our linear function. Now we get to test it. Because is they want us to figure out, based on this information, what would the dog have weighed at 2, and what would the dog have weighed at 7? Let's find out. Oh, let me label X and Y here, just to keep this clear, because the formula, as you can see, has X's and Y's in it. Remember, X is the independent variable, and Y is the dependent variable. So I'm going to replace the X, number of years, with a 2 for this first one, figure out the dog's weight at 2, and then I'll do it again, but use a 7, figure out what the dog's weight would be at age 7, using this function. Oh, that 5, okay, that's better. Alright, so I'm just going to plug that into a calculator. Let's clear that. Yep. There's our slope. Times 2 for 2 years. Remember, the slope represents how much the dog is gaining every year. So, if we're doing 2 years, we have to multiply it by 2. According to our formula, oops, wait, let me fix that. According to our function here, the dog after 2 years would weigh 238.75 pounds. Now, we are going to eventually comment on the validity of the model, but just thinking about this right now, think about how much you weigh, and think about the biggest dog you've ever seen, and start to think if this is making sense. Let's just let that simmer in the back of your mind. So at age 2, according to this function, the dog would weigh 238.75 pounds. So let's figure out at age 7. I'm just going to go back and I'm just going to change this 2 into a 7. And apparently, at 7 years old, this dog weighs over 800 pounds. Oops, did I freeze my screen? Nope, I didn't. Sorry. Alright, so at age 7, the dog weighs 832.5 pounds. So, let's think about this. Does that seem like a likely weight for a dog? Now, the problem specifically said Newfoundland dog. That's one of the biggest dogs ever. I've never actually seen one, but I'd love to. So, at age 7, according... Did I spell the according right? According to the function, the dog would weigh 832.5 pounds. And then we have to figure out, is this valid? Now, hopefully you've been thinking about this in the back of your mind and thinking, these numbers seem a little bit large for the weight of a dog. So is the function valid? Now, just to verify, there's no harm in looking it up. Average weight of a Newfoundland dog, looks like the male maxes out at 180 pounds. Not 800 pounds. So, no, this is not a valid model. And you think about it, most life forms don't grow at a linear rate. Like, you have not gained the same amount of weight every single year your whole life. Or you have not grown the same amount of inches taller every single year your whole life. Maybe you had a growth spurt when you were a kid. But eventually, things kind of level off. Most biological life forms can't continue to grow at the exact same rate every single year. Clearly, as in the case of this dog here, if it could, that'd be a really big dog. So a linear model, a linear function is not going to be valid for every kind of situation. It's definitely not going to be valid for this kind of situation.